Hey all, I'm Scott Fielder. I'm going to be your C++ teacher for this semester. And our first assignment, assignment 1, is going to be doing a physics demonstration. I'm up here on top of a 4-story building, and I'm going to drop a water balloon off of here. We're going to get some timing data from it, and from that we're going to do our first game simulation of a falling object. All right, here we go. What do you think? All right, I'm back in the studio now. I want to go over the mathematics of that water balloon drop. Let me fire up my tablet and I'll show you what I'm talking about. All right, so I'm going to draw a little wall here for you. And I'm going to draw a water balloon here and then let this thing fall down to the ground where it's going to make a big splash. The entire event is going to take 1.6 seconds. But in order to work out the math for this thing, we're going to have to actually come up with a coordinate system. So we're going to define the y-axis as being up and down. We're going to define the x-axis as being back and forth. And we're going to define the z-axis as coming out right at you. All right? All right, so the water balloon is going to fall down the y-axis. And my first question would be, well, how high up was that balloon when I first dropped it? Now, if it's going to take 1.6 seconds to fall to the ground and gravity is what's pulling it down, I should be able to calculate that using one of Newton's laws. So I went over to the website, or a website, and looked up Newton's law for you. And this is what I found. And oh dear, look what I see in there. I see calculus in there, and I thought, I can't do that to you. First day of class, first day of C++ class. So I decided, skip that. I got a better idea. What if we do this? What if I derive an equation of motion for you? You'll learn more about all this stuff in a physics class, but I'll write out the basic equation. We'll do some quick calculations and we'll find out how high up that ball was, all right? Let me show you what I'm talking about. All right, I took the first law and the second law from Newton, kind of combined them, and I created this equation for you, which is that y, the position at the end, is going to be equal to the original position plus velocity originally times time plus 1/2 the acceleration. Now the acceleration in this case is going to be gravity. So I took the ball and I let it go, and as it falls, gravity's pulling it down. So rather than using acceleration, the letter A, which you'll see in a lot of books, I'm going to use the letter G for it in this particular case. All right? So that's going to be 1/2 G times time squared. Now, this is going to be the final position of the water balloon. Now, where's that water balloon going to land? Well, it lands on the ground. So when I wrote out the coordinate system for us, I did something like this, and I said this is going to be positive y-axis, and there's the ground. So this down here would be the origin. That would be at 0. So the balloon is going to end up at 0, and then this is the height it was originally. The original velocity. Now, hey, that's kind of cool. If I took the ball or the balloon and let it fall, its original velocity was 0. So you know what? I can just lose that term completely. Let's do a little algebra to clean this mess up. So we're going to say y minus y0, I'm going to take this y0 and put it on this side of the equal sign, is then going to be equal to 1/2 acceleration, which is g, times time squared. All right? Now, since its final resting place is going to be at 0, this is 0 minus y0. So this just becomes negative y0 is equal to 1/2 gt squared. In fact, you know what I can do? If I just remove the minus sign here, you put it over on the other side, and I get y0 is equal to negative 1/2 gt squared. Simple. Now this should be easy to calculate. y0 is equal to negative 1/2, all right, times negative 9.8 times, I'm going to put this in parentheses, 1.6 seconds squared. All right, now why negative 9.8? Well, the coordinate system has y going up. And if y is going to go up and the balloon is coming down, gravity must be pulling it. So gravity must have a directional force of negative on this, so I'm going to put a negative sign in there. The negative here, they cancel. I'll tell you what, let's go get a calculator and see what the answer is. Can't find my big calculator, so I'm just going to have to use the brain. Let's see what I can work out here. If you take negative 1/2 times negative 9.8, that should be about 4.9. If you then multiply that by 1.6, that should give you 7.84. And if you multiply that then by 1.6 again for the square, that should be 12.544, which turns out to be the answer. I love this stuff. Alrighty, so now we got some data. So we're going to have a water balloon sitting up at 12.5 meters above the ground. We're going to drop it. It should take 1.6 seconds to hit the ground. And we're going to do in the next episode a simulation, a computer simulation of that same event. And let's see if we can get the same numbers to pop out. And we're on our way to making games. Games are just simulations of things and where you keep score. Okay? All right.